Hey, let's keep going. So, we did A and B, or number 1 A and B. We are now on number 2A. We got to find the derivatives here. So, essentially, we're looking at, again, just in case you forgot, product, quotient, chain rule. So, h of x is this guy here, and you can see that it is a big product. So, h prime of x is going to be, product rule says derive the first, which is 2x, times the second, which is cotangent x, and then add on the first, x squared, times the derivative of the second, which is negative cosecant of x. So your final answer, just to write this out somewhat nicely, is 2x cotangent x minus x squared cosecant x. Okay, and did I do something wrong here? Yeah, derivative cotangent is cosecant squared. There we go. Gotta put that square there. All right. Hopefully you knew that. You were yelling at me back here. Okay. Let's keep going. Get out of here. Yeah, get out of here. Blah blah blah. There we go. Letter B. We've got x squared minus 5x over square root x plus 5. Okay. And on the bottom here, only x is in that square root. That's a plus 5 outside the square root. So this is a big quotient. We got to do the awesome quotient rule. So k prime of x is going to be, quotient rule says derive the top first. That's going to be 2x minus 5. I'm going to multiply that by the bottom, which is root x plus 5. Minus, now we're going to derive the bottom. Square root of x, derivative of that is 1/2 x to the negative 1/2, or 1 over 2 root x, same thing, times the top, which is x squared minus 5x. Here we are, and all that is over the bottom squared, and the bottom squared is root x plus 5 squared. Do not write x plus 25. That does not turn into x plus 25. All right, that's the derivative. That's the calculus. We're done all the hard work. Now, again, I don't like negative exponents, so what we're going to do is, multiply through by x to the positive 1/2, well, 2x to the positive 1/2, because we want to cancel this out. So I'm going to multiply the top by 2x to the 1/2 and the bottom by 2x to the 1/2. Alright, and that's going to cancel out this 1/2 x to the negative 1/2. So our final answer is really going to be, now 2x to the 1/2, we multiply it into this thing here, because this is all one big term. It's not going to really simplify with this root x, because you got the plus 5 there and everything. I'm just going to write it up front. It's just going to be 2x to the 1/2 times 2x minus 5 times square root x plus 5 minus, now 2x to the 1/2, when you multiply it by this stuff, is going to kill this 1/2 x to the negative 1/2. They're gone. So what we're left with is x squared minus 5x, and it's still in parentheses, just subtracting the whole thing, all over the square root of x plus 5 squared times 2x to the 1/2. Now we might be able to simplify this down some if we expand out this thing and multiply it in. I'm really not too interested in that. That's a lot of work. It's not even calculus, so I really don't even care, to be honest with you. If I had to use it to solve some equation or something, I might simplify it down some. But this is all I really need you to do. If you've got a different teacher and they're making you do all kinds of extra work, sucks to be you, I guess. I don't know. Multiply it all out. You can do it. It's algebra. I'm not going to get into it. Okay, probably not the best teaching method there, but oh well. What are you gonna do? Okay, C, B of this W-looking dude. I don't know, omega. I don't even know what that is, to be honest with you. I mean, I learned it somewhere along the line. It really doesn't matter. It's just a variable. It's just like x. Okay, I'm gonna call it omega. If it's not omega, I apologize. So B prime of this dude is equal to, and now we've got to do the chain rule, because we've got cosecant of a function, so it's a function inside of a function. So we look for the outside function, and that is cosecant. The derivative of cosecant is negative cosecant of what's inside, which is the square root of this dude, and then cotangent of what's inside, which is the same thing, square root of this dude. Okay, that's the derivative of cosecant. We're done. Now we move to the next layer. Again, it's like peeling an onion, like Shrek. They got layers. So you derive the outside layer, you're done. Hello, Maddie. Get out of here. Sorry, my dogs want to learn calculus too. Let me think here. Okay, where was I? Alright, we derived cosecant. Now we're on the inside layer here, the square root. Now this is also a function inside of a function. I know you're thinking, oh my god, a function inside a function inside a function. Yeah, I went there. What are you going to do? So we got to derive the square root now. Well, that's fine. We've derived square roots a bunch of times. We got 1/2, and now we're going to have what's inside stays the same, and that's to the negative 1/2. Now we derive the square root. Perfect. Now we move inside to the next layer. Well, to derive this, again, we're treating this omega guy as x. It's just a variable. So the derivative of omega minus 5 omega squared is, I hope this is omega. I'm going to feel stupid if it's not. But what are you going to do? Alright, well, the derive of just omega by itself is 1 minus 10 omega. Because you bring down the 2, it becomes a 10, w to the first. And you're done. The only thing that I would recommend is, well, you need another parenthesis first off, Mr. Smith. And the second thing is you don't want to leave a negative exponent here. Since this is to a negative exponent, I would rewrite this and put this w minus 5w squared, omega minus 5 omega squared, on the bottom to the 1/2. So I'm not going to rewrite it because you can do it. It's going to be multiplied all together and then put this thing on the bottom. And there'll be a 2 with it because of the 1/2. Okay. Clear markup. Faux show. Okay. D. We got beta of theta. Alright. Nothing wrong with that. And I put an x in there. God dang it. This should be a theta right here. I don't know why I do this. I always try to use different variables and I always mess it up. Every single year. It never fails. But anyway, it's theta squared sine of theta cotangent theta. Alright, so beta prime of theta is going to be, you can see we've got a quotient rule, so we got to take care of that. And to do the quotient rule, we need to derive the top. However, oh no, the top is a product. And you're thinking, Smith, you got to be crazy. And you're right, crazy awesome. So, let's go ahead. I have too much time on my hand, apparently. Let's go ahead and derive the top. So we got to do the product rule. So we'll derive theta squared first. That becomes 2 theta times the second thing, sine of theta, plus, now we derive the second part. Sine of theta turns into cosine theta when you derive it. So we take the top times the derivative of the, no, I'm sorry, not the top, the first thing times the derivative of the second thing. This is the derivative of the top. Do not lose track of what you're doing here. We just derived the top. We're going to multiply that by the bottom, cotangent of theta. Then we're going to subtract off. Now we need to derive the bottom. The derivative of cotangent is negative cosecant squared. So that's going to turn this into plus cosecant squared theta. Put them in parentheses. We can put these guys in parentheses too. Okay. There we go. So, I don't know if you guys can hear, but my dog is growling. She's going crazy. She's ready to play. Anyway, we derive the bottom. Cosecant squared theta, that's cotangent, derivative of that, times the top now. I'll put in parentheses just so we know we're multiplying. You don't really need those there, but I'm going to put them there anyway. I'm going to parentheses heavy. There we go. So, derivative of the top times the bottom, plus or minus derivative of the bottom times the top. It's a plus because the derivative of the bottom was negative. All of that is over the bottom squared, which is cotangent squared. And I'm not even going to try to cancel these things out here because this cotangent here will cancel with the cotangent here, but not over here. So you'd have to split up the fractions. It would be all a big mess. You could multiply cotangent in. Don't worry about it, though. This is a sine, an S, not a 5. Okay, that's fine. That's a perfectly fine answer for the derivative. Okay, let's do E. E is this giant quadratic mess. So n prime of x. I hope you can hear these dogs. They're about to go crazy. No, here they go. Girls, hey. All right, very good. Go play in the other room. They are looking at me like I'm crazy. They don't care. All right, n prime of x. It's a quotient. We're going to drive the top times the bottom. So we're going to have 2x minus 5. That's the derivative of the top. times the bottom, which is x squared plus 3x minus it. Minus the derivative of the bottom, which is 2x plus 3. Times the top, which is x squared minus 5x plus 4. And all of that is over the bottom squared. So we're going to have this quadratic thing. X squared plus 3x minus 8 squared. There you go. You're done. That's calculus. Now, since this isn't too bad, you should multiply this out and simplify it. You're going to have to do this later on in the year when we start looking at graphing from derivatives. You're going to have to simplify this thing. So let's do it now. So with 2x times x squared is 2x cubed. I'm going to kind of do this quick. I might make a mistake. If I do, forgive me. We're going to have 3x squared. No, I'm sorry. 2x and 3 makes 6x squared. Minus 5x squared is 1x squared. No problem. Minus 16x minus 15x is minus 31x. And then negative 5, negative 8 make plus 40. Minus 2x and x squared make 2x cubed. Perfect. Minus 10x squared plus 3x squared is minus 7x squared. Plus, what is this, a 4? Yeah, 4. Okay. Sorry, my screen's all cracked, so I got this like big black mark in front of this. Anyway, 2x times 4 is 8x. 3 and negative 5x make negative 15x. So that's going to make negative 7x. Because 8 and negative 15, and then 3 and 4 make 12. And all of that is still over this bottom guy squared. So, this is super annoying, but we're doing it. Squared. And now we just got to put all these things together. So I'm going to come up here. N prime of x is going to be, let's switch to red so we cancel these again. This is fun. This is my kind of fun, yeah. 2x cubed minus 2x cubed is going to go away. Woohoo, that was awesome. That's really all we can do. Now we've got x squared minus negative 7x squared. Well, that happens to be 8x squared. Then we've got negative 31x minus negative 7x, which is the same thing as negative 31x plus 7x. And that happens to give us, what, negative 24x. Then we got plus 40 minus 12. That's 28. And all of this is over x squared plus 3x minus 8 squared. Now, sometimes, especially in like textbook problems, they work out kind of nice where this top is going to end up factoring and canceling with the bottom. Usually ends up working out pretty well. In this case, it's probably not going to happen because I just made this up. So we're done. This is the derivative. If you had to work with this and like set it equal to 0 or find out where it's like positive or whatever, I would try and factor it and see what I could do. But right now I'm not worried about it. The question said to derive. I derived it. There it is. All right. Halfway done, those guys.